Hi friends, welcome to my YouTube channel. I'm trying to solve all the problems from this book, from this physics textbook, and this book is basically based on American curriculum, but some schools in Thailand also use the same book. And I will be solving different worksheets from this textbook, and today I'm solving the worksheet Overcoming Friction from the page number 139 from this textbook. I'm going to solve the first problem. So first I will read. A student pulls on a rope attached to a box of books and moves the box down the hall. The student pulls with a force of 185 Newton at an angle of 25 degree above the horizontal. So that we can list that is the applied force here. F applied, or simply we can write as FA, that is 185 Newton of force, and that is acting at an angle of 25 degree above the horizontal. Okay, and the box that has a mass of 35 kilograms, so the mass of the box it is 35 kilogram, and mu k between the box and the floor is 0.27. So we know what is mu k. Mu k is coefficient of kinetic friction, that is equal to 0.27, and find the acceleration of the box. The question is to find the acceleration acting on the box, or acceleration of the box. So just first we can draw the free body diagram. So there is a horizontal floor, and on the horizontal floor there is a box. Okay, this is our box, and there is a rope attached with the box, and let be the rope attached with the box, and the applied force is along this rope. So this is the applied force, and this applied force makes an angle of 25 degree above the horizontal. And we know that, of course, the weight that we can write as Fg, that is a weight, I'm writing here, weight Fg, that will be always acting exact downward, and weight that is equal to mg here. And of course there will be a normal force acting equal and opposite, so it will be Fn. So that is the normal force acting on the object, that is Fn. That also we have to find here. So first we have to find the net force. We know that the net force that only create the acceleration of the object. So here we have to find the net force, and from the net force only we can find the acceleration of the object. So first we can write the force equation, that is the net force acting on the object, that will be equal to the applied force, or simply we can write as FA like this, minus the kinetic frictional force. Of course I haven't marked the kinetic frictional force here. See, this will be the direction of kinetic frictional force, because the motion is happening along this direction, and the frictional force will be opposite to that. So this is the kinetic frictional force here. So to find the kinetic frictional force, we have given the mu k, but the normal force is not given. So first we have to find the normal force, then only we can find the net force, and this net force only create the acceleration. And according to Newton's second law, we know that net force that create an acceleration and is equal to ma. Net force equal to ma. So first we have to find the normal force. So how to find the normal force? See, this is the normal force here. There is an applied force here. So this applied force is at an angle of 25 degree with respect to the horizontal. So here we can resolve this applied force into two components. This is the x component of the applied force, which is along the direction of motion, and this is the y component of the applied force, which is perpendicular to the motion and which is acting along the same direction as that of the normal force. And here in this vertical direction there is no motion, so all the forces along this vertical direction should cancel each other. So here we can see the normal force acting upward, the y component of the applied force is also acting upward, and the gravitational force, or the weight of the object, that is acting downward. So here all that forces, that is the second force equation of this problem, that is a normal force plus the y component of the applied force minus the gravity, that should be equal to 0. So here Fay that we have to find, that is a y component of the applied force. So we can resolve the FA into two components, X component and Y component. So what will be the X component here? The X component, we know that is the applied force magnitude times cos of the angle. It is 25 degree here. And what is the magnitude? It is 185. 185 times cos 25 degree. And the answer is around 167.67 Newton. And FAY, that will be magnitude of the applied force times sine 25. So 185 times sine 25 degree, and it is around 78.18 Newton. So once we know the value of FAY, we already know the value of FG. Okay, we didn't find the value of FG, that we have to find here. What is FG? That is mass, that is 35 times 9.81. So its value is equal to 343.35, that much Newton. So that we can substitute in this relation. So this is our first relation and this is our second relation. Okay, that we can substitute in the second relation and we can find the value of normal force. So I'm just rearranging this equation to isolate the normal force. So Fn, that's equal to Fg minus Fay. What is Fg? It is 343.35 minus Fay, it is 78.18. And the Fn value, the normal force, it is around 265.17 Newton. Okay. And yes, so that is the value Fn. So now we can find the frictional force. So what is frictional force? Frictional force is frictional force, that we know that it is the coefficient of friction times the normal force. And we have the applied force, we have the frictional force also. So that we can substitute in the equation number 1, that is the net force is equal to applied force X component. I'm sorry, here it should be applied force X component because that is only along the horizontal direction. So applied force X component minus, I'm only writing FAX, that means applied force X component minus FK. So the X component, it is 167.67 minus Fk. What is Fk? It is mu k times Fn. The mu k value is here, it is 0.27. So that minus 0.27 times Fn. Fn is 265.17. So the value for the net force is around 96.07 Newton. So this is the net force acting on the object. So once we know the net force, we can easily find the acceleration, because the net force that create the acceleration, that is mass times acceleration. So acceleration is the net force by mass. Net force is 96.07, that divided by mass. Mass, it is 35 kilogram. So the acceleration is around 2.7 meter per second square. So the acceleration value, what we get, it is 2.7 meter per second square. And also we should specify the direction of acceleration also. So how to specify the direction of acceleration? So we have the question here. See here, you can see the box moves down the horse. So that will be along, okay, we can write it as positive x direction. So this is how we solve. First we have drawn the force diagram, then we have resolved the applied force into two components, then we have written the force equations, we found the normal force, then we found the kinetic, frictional force, and then for the net force, from the net force equation we found the net force acting on the object, and later we found the acceleration of the object. Thank you. And it's our second problem. The student in item 1 moves the box up a ramp inclined at 12 degree with the horizontal, and if the box starts from rest at the bottom of the ramp and is pulled at an angle of 25 degree with respect to the incline and with the same 185 Newton force, what is the acceleration up the ramp? Assume the kinetic friction coefficient mu k is equal to 0.27. So this question we have to use the same data from the question number 1. So we can write the same mass here, and I remember the question 1, the mass is 35 kilogram. The mass is 35 kilogram, and here also the box moves up a ramp. Okay, so we have to draw the free body diagram, but the diagram here it is slightly complicated, but we can make it simple. See, there is an inclined plane here, and the inclined plane, it is inclined at an angle of 12 degree with respect to the horizontal and the box here. Okay, and of course we know that the gravitational force or the weight of the box that act downward, we can represent it as Fg. So first we are resolving this Fg only, then we can move to the next component. Okay, so here this Fg we can resolve into two components. And of course this 12 degree will also come here also. So it will be x component of the gravitational force, and it will be the y component of the gravitational force. So the gravitational force acting on the object, that is mass times gravity, that we have to find Fg value. It is mass, it is 35 times 9.81, it is around 343 Newton, and the x component of the gravity and the y component of the gravitational force acting on the object, x and y component of the weight acting on the object, simply we can say. So this x component, that is equal to Fg, that is the magnitude of the gravitational force times cos theta, and theta here it will be 12, so it is 343 times cos 12 degree, and the answer is around 335.5 Newton, and y component it is Fg sin theta, that is equal to magnitude of the gravitational force 343 times sin 12 is equal to 71.38 Newton. Okay. Yeah. So that are the two components of the gravitational force acting on the object. So now we have to draw the normal force acting on the object. We know that the normal force will be acting exactly upward or exactly perpendicular to the object. And here we know that the normal force, when an object is on a horizontal surface, the normal force and the cos theta component of the gravitational force will be in the same line. Of course, it should be exact perpendicular. And now, yes, the student also pulls. The student, see, it's given here, the student, where it is, the student pull at an angle of 25 degree with respect to the incline with the same 185 force. So there is an applied force by the student, and that applied force is making an angle of 25 degree. So that is Fa. So here applied force is not parallel, applied force is making another angle. So this applied force also we can resolve into two components. First we can write applied force here, force applied, or is simply Fa, that is equal to 185 Newton force at an angle of 25 degree with respect to the incline. Okay, so this applied force we can resolve. This applied force we can resolve into two components, that is x component and y component. Okay, so the x component of the applied force, that's equal to applied force magnitude times cos of the angle. Here it is 25. What is the magnitude? It is 185 times cos 25, and the answer is around 167.67 Newton, and the y component of the applied force, that is equal to Fa sine 25, that is around 185 times sine 25, that's equal to 78.18 Newton. So now we have all the forces acting on the object. See, we can see the normal force, the applied force y component act perpendicular to the object, and along the same direction the gravitational force x component also act, and there is no motion along this direction. So we can equate this, or sum of all these forces should be equal to 0. So that is equal to, that means the normal force plus y component of the applied force minus the x component of the gravitational force. Why minus here? Because the gravitational force we can see here, that is acting opposite to the direction of the normal force and the y component of the applied force. That's why the negative comes, that's equal to 0, because there is no vertical motion. Okay, now we can isolate Fn. So Fn, that's equal to the x component of the gravitational force minus y component of the applied force, that's equal to what is the x component of the gravitational force? It is here, it is 35.5 minus y component of the applied force, it is here 78.18. So the normal force acting on the object is around 257.32 Newton. And now we can write the net force. The net force here, see, the gravitational force y component acting in this direction, applied force x component acting in this direction. Of course, mu k is given. See here, mu k is given. What is the value of mu k? It is 0.27. So of course there is a kinetic frictional force, and of course we know that the kinetic friction that opposes the motion, so that will be along the direction of the y component of the gravity. So here we can write as F applied force x component minus the gravitational force y component minus the kinetic frictional force, that is equal to the net force. Okay, so the net force is equal to Fax, it's given here 167.67 minus Fk. What is Fk? Oh, that is a kinetic friction, frictional force Fk, that is mu k times Fn. That we haven't found, we have to find. It is 0.27 times 257.32, and its value is around 69.47 Newton. Okay, that is the kinetic frictional force. It is 69, not 67, 69.47 minus the Fgy also. The Fgy, it is 71.3, and the net force is around 26.82 Newton. So now we have the net force. So when we have the net force, we can find the acceleration easily, because the net force is equal to mass times acceleration. So what is from this equation, acceleration is equal to net force divided by mass. So net force here, it is 26.82 divided by 35. So the answer is around 0.77 meter per second square. That is the acceleration of the object. Okay. Only thing that we have to consider about this force diagram. Once the force diagram is done, you can just equate the forces. And when there is no motion, the forces will add up to 0. And when there is a motion along one direction, the net force will be along that direction. Okay. So this is our third problem in the same worksheet. A 75 kilogram box slides down a 25-degree ramp with an acceleration of 3.60 meter per second square. Find the mu k between the box and the ramp. And also there is one more question. What acceleration would a 175 kilogram box have on this ramp? So both problem we have to do. So first, can go to the first problem, problem A. So the mass is given M it is 75 kilogram, and the box slides. Yes, the box slides down a 25-degree ramp with an acceleration of 3.60 meter per second square. So here the acceleration is given. We have to find the coefficient of kinetic friction. So what we can do, we can draw the force diagram, and there is no external force acting. That is not given. So that we can assume there is no net external force. There is no external force. Of course, there will be net force. So there is an object that sliding down, it is given. So this is the motion, direction of motion. Of course, the weight that will act downward, and there will be a normal force also. This is the normal force, and the weight acting downward, it is 25 degree, inclined at an angle of 25 degree, it is given. So we can resolve it into two, that is Fg, x component 25 degree will come here also, and this Fg, y component, and of course the frictional force which is opposite to the motion, that is acting opposite. So here the mass is given. We don't know the value of Fg. So first we have to find the value of Fg. That is the weight of the object. So it is mass times acceleration, or mass times acceleration due to gravity. That we can find mg value. It is mass, it is 75 times 9.81. So that's equal to 735.75 Newton. That is the weight of the object. And see here, it is given the acceleration of the object is given in the question. It is 3.60 meter per second square, it is given. So acceleration, it is given as 3.60 meter per second square. So who create the acceleration? The net force only create the acceleration. So from this we can find the net force, that is equal to mass times acceleration. Mass, it is 75 times 3.60, that is around 270 Newton. That is a net force acting on the object. So what is the net force here? That is the actual, here it is the motion is happening along this direction. So of course the net force will be along the same direction. And the net force, that's equal to the y component of the gravitational force minus the frictional force. So from this we can find the frictional force. From that we can find the coefficient of kinetic friction. So here the net force, what we know, it is the y component of the gravitational force minus the frictional force. So we should find the y component and x component of the gravitational force, that we can resolve here. The x component of the gravitational force, that is Fg cos theta, that is Fg. What is Fg value? It is 735.75. 735.75 times cos 25. The x component is 666.77 Newton, and the y component Fgy is Fg sin theta, that's equal to 735.75 times sin 25, that's equal to 310.94 Newton. Okay, so this Fgy, that is 310.94 minus Fk, and F net force, that is 270, that we know. So from this we can find the value of Fk. Fk is equal to 310.94 minus 270, that's equal to, the frictional force acting on the object is around 40.94 Newton. So once you know the frictional force, you can find the coefficient mu k, that is equal to Fk by Fn. So the normal force that we have to know here, see, when an object is on an inclined plane and there is no external force acting on the object, so in that case the normal force is balanced by the x component of the gravitational force. So that we found here. So this is also equal to the normal force. Okay. So that value we can substitute here. Fk is 40.94, that divided by 666.77. So that value is equal to 0.061. So that is the coefficient of kinetic friction, and the coefficient of kinetic friction, it doesn't have any unit because it is a ratio of force to force. Okay, so that's the first A part. In the B part, what acceleration would a 175 kilogram box have on this ramp? So the same ramp, same inclination, but what is the difference? The difference is the mass in the mass of the box. So the 25-degree ramp is there is a big box, okay, the box, and the weight is acting downward, that is Fg. Then of course the normal force that will act upward. Then this angle will also be 25 degree. You can resolve Fg into two components, Fgx and Fgy. And here the mass, it is 175. Mass it is 175 kilogram. And we have to find the acceleration. So the same procedure we have to do in the question number 1 and 2 what we have followed, but it is more simple here because there is no external force acting. Only the force here, it is the gravitational force and the normal force. So here first we have to resolve the Fg into two components, Fgx and Fgy. And Fg here it is, first we have to find, that is 175 times 9.81, that is mg, and this value is equal to 1716.75 Newton. Now we have resolving Fgx, that is Fg cos theta, that's equal to 1716.75 times cos of 25, the x component value, that's equal to 1554 times 32 Newton, and the y component, that's equal to Fg sin theta, that is 1716.75 times sine of the angle 25 degree, and that's equal to 724.79 Newton. So here also the Fgx balance with the normal force. So with that also we can write the normal force here, that is equal to Fgx. So that's equal to 1554.32 Newton. And the kinetic frictional force Fk, that we can found from mu k into Fn, right? So mu k, it is, see here the mu k value is not given, but it is given the same plane, same ramp it is given. So here we found the value of mu k, we can take the same value. I am writing here the mu k value, it is 0.061 itself you can take. It is 0.061 times Fn, that is 1554 times 32, that is equal to 94.81 Newton. So now we have to find the net force acting on the object. So the net force acting on the object, that is equal to, see here there are two forces only, the gravitational force y component, and of course there is a kinetic frictional force Fk that will be acting, that is I didn't mark first, so it is Fgy minus Fk. 724.79 is minus 79 minus 94.81. So the net force is around 629.98 Newton. So now we can find the acceleration. The net force equal to mass times acceleration. That implies acceleration is equal to net force divided by mass. So what is net force divided here? It is 629.98 divided by mass. Mass it is 175. So it is 3.61 meter per second square. So that's two problems. This is our last problem in the worksheet, the fourth one. A box of books weighing 325 Newton moves at a constant velocity across the floor when the box is when the box is pushed with a force of 425 Newton exerted downward at an angle of 35.2 degree below the horizontal, find mu k between the box and the floor. So first we can list the things. It's always better to list the things that is given in the problem. When you list the values that is given in the problem, then there is no need to go through the problem again and again. So here a box of books that is weighing 325 Newton. See here, it is given it is weighing 325 Newton. You have, see here it is given as the unit Newton. That means that the thing here given here, it is the weight of the object, and it is, of course, it is given weighing. So weight of the object, of course, what is weight? That is the gravitational force acting on the object, that is 325 Newton. That moves at a constant velocity. See, that moves at a constant velocity means acceleration is 0, because it is given as constant velocity. Because acceleration is the velocity change. When velocity is not changing, acceleration will be 0. That means constant. Constant means it is not changing. And that moves across the floor when the box is pushed with a force of 425 Newton. So that is the applied force here. Simply FA, it is 425 Newton exerted downward at an angle of 35.2 degree below the horizontal. Okay, it is below the horizontal. And what do you have to find? We have to find the mu k. So first we can draw the free body diagram. The horizontal floor is here, the box. Okay, and yeah, there is an applied force of 425 Newton. Of course, the gravitational force is acting downward, normal force is acting upward, and there is an exerted force, and it is below the horizontal applied. So applied force is here below the horizontal, and it is making an angle of 35.2 degree. So these are the three forces acting. So here applied force is making an angle of 35.2 degree. So we can resolve applied force into two components. That is the applied force, this angle that should come here, right? Because it is given like, see, pushed with a force of 425 Newton exerted downward at an angle of 35 degree below the horizontal. So the angle should come here, not here. I'm sorry, that's my mistake. So it is 35.2 degrees. So here the x component, and it will be the y component, because below the horizontal, the angle is specified with respect to the horizontal, not with respect to the vertical. So it should be marked here with respect to the horizontal direction. So here is the x component, and this is the y component. So we can resolve the applied force component into two, Fax and Fay. But anyway, we have done some problems, so I'm not writing that directly here. We can directly move to the force equation. Okay, in that force equation only we are going to substitute all those values. So what will be the force equation? First one, the vertical forces we can, normal force acting upward, gravitational force acting downward, y component of the applied force is also acting downward. So here the normal force minus the gravitational force minus the y component of the applied force, that is equal to 0. And of course, there is also given that the net force or the acceleration is 0. So when the acceleration is 0, that means that there is no net force acting on the object, because acceleration is equal to 0. Okay. So here the net force is 0. What is net force actually here? That is the applied force of the x component minus the kinetic frictional force. So these two should have the same magnitude. So the applied force x component, that should be equal to the kinetic frictional force Fk. So first we can take our first relation. This is first one, this is the second one. So first relation, from the first relation we can find the normal force, then only we can find the Fk value. Then only we can find the mu k value. And here the normal force Fn, that is equal to, I am rearranging this relation to isolate the normal force Fn. Fn is equal to Fay minus Fg. What is Fay? That is applied force y component, applied force Fa sin theta minus Fg. So what is Fa sin theta? It is 325 times sine of 35.2 minus Fg. Fg it is, my bad. Applied force is 425, not 325. 425 times sine of 35.2 minus Fg. It is 325. So the normal force here acting on the object, that is around 560. And see here, here the normal force Fn is equal to Fay plus Fg. It will become, because both are minus here. So it will become plus Fg. Here also it will become plus. Here also it will become plus. So the answer is around 569.98 Newton. Of course, we know that whatever in the left, in the minus sign or in the negative sign, when it is going to the other side of the equality sign, it will become plus. So it should be plus here. So it is 569.98 Newton. That is the normal force acting on the object. So that is the Fax, or the kinetic frictional force component. Now we can find the value of mu k. Our question is to find mu k only. That is the coefficient of kinetic friction, mu k, that is equal to Fk by Fn. What is Fk? It is 347.29 divided by 569.98, and the value is around 0.609. That is the value of coefficient of kinetic friction.